Today's space question is from Sean, and he wants to know why it takes less propellant to fly out of the solar system than it does to go into the sun. And the short answer to that is that the Earth is moving very fast. It's moving so fast, in fact, that in the time it would take to fall into the sun, it's moving horizontally so fast that it just goes around. And that's actually the definition of orbit. Now, what that means, though, is if you want to get closer to the sun, you need to slow down. And if you want to get very close to the sun, you need to slow down a lot. And if you want to go into the sun, you basically need to cancel all of the horizontal velocity that the Earth has around the sun. Now, to visualize how hard this is, we can take a look at the Parker Solar Probe, which is the closest we've sent a probe to the sun. And this was a very small probe, but we launched it on an enormous rocket going very, very fast. It flown around Venus several times to get gravity assists to go even lower into the sun. And after all of that, it only made it about 4% of the distance between the Earth and the sun. So it got close enough to go into some of the chromosphere, but wouldn't even classify as into the sun for what I assume this question is implying. Now, in contrast, leaving the solar system basically just requires adding a bit of extra velocity to make it so that by the time you make it out of the solar system, you're moving at 0 meters per second, and that's the definition of escape velocity. And it turns out for Earth, the escape velocity out of the solar system is much less than the orbital velocity of Earth currently around the sun. So keep that in mind next time you're threatening to throw your enemies into the sun. That it's actually a lot easier to throw them out of the solar system.